So Delta says, while a graph is a useful tool for estimating, it's often difficult to find an exact answer on a graph. What's significant about the point labeled 1y? So again, we're talking about the point that is labeled right here is 1 for x, come up, y. So for this one here, what's significant about it is that's my unit rate. Whatever that y-intercept is my unit rate. And so I'm going to come right back over here. 1y is significant because y is the unit rate. And that's important. Once I find that 1 for x, whatever my y is going to be my unit rate. And if I have that exact point, it's perfect. It's awesome. Again, it's kind of difficult to find. But what we're going to do is we're going to use a table in part B and my result in part D to find his unit rate. So what they mean is up here, I have 0. I have all of these. I guess I should do it on the paper. Well, we have all of these right here. And that's helpful, but what we really want to also have is we want to know what 1 gallon of gas, how many miles that's worth, or 1 gallon. So how can I figure that out? Well, if I go from here to here, I'm going to divide by 12 because 12 divided by 12 is 1. So I'm going to take my 420 and I'm also going to divide that by 12. And whatever that answer is going to be how far he can go on 1 gallon of gas, which is my unit rate. So I'm going to go ahead and do that down here in Echo. So I have my dividend and my divisor. I'm going to find my quotient. So I have 12 down here. So I'm asking how many 12s are in 42. So I see 3 of them. 3 times 12 is 36, and I'm going to subtract the difference. So I'm going to get 3 here, and so I'm going to have 6 right there. I'm going to bring down that 0. How many 12s are in 60? That would be 5. 5 times 12 is 60. Oops, I'm going into F. So my unit rate really is 35 miles per 1 gallon of gas. That's what my really, which is, and it's close to what we have here, but there's no way I would have gotten 35 from the graph itself.